Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you and came across this at The Guardian. This should be entertaining, to say the very least, but yes, very interesting too. Yes, fusion power might be 30 years away, but we will reap its benefits well before. Interesting. Discoveries made in pursuit of nuclear fusion have potentially huge practical applications in everything from curing cancer to superior batteries for EVs. Yeah, think about the NASA's original space program back in the 60s. We got Velcro and a whole bunch of other stuff like that. I think titanium was another thing that came out of the space program. Again, there are many more. If you can think of any, as I say, I'm not a scientist myself. Pop them down in the comments, because there was a lot of benefits from the space program. And this, nuclear fusion, looks like it's going to give us some more too. Absolutely amazing. Absolutely fascinating. Now, when James Watt's first commercial steam engine was installed in March 1776 at Bloomfield Colliery, Tipton in the West Midlands, it was hailed as a mechanical marvel, yet few could have anticipated the way steam engines would change the world. Yes, very much the same as the interzones and computers when they first came along. What's the point of that? Oh, I can't see it, because people have got such small minds. Humans are fascinating to me. You can't see the potential? Like a mate of mine who built a solar barbecue from bits in his backyard based on an old beach umbrella. Got a beach umbrella, literally took the handle, the long handle off it, still had a bit of the spike from the handle, had the inverted umbrella opened up, made a little base for it, lined the inside started off with aluminium foil, and was able to literally cook something. And then the reason everyone laughed is because the outside cover, the only thing he had, was made from his pajamas or, I don't know, some kind of rug or something or other. His mum put it together for him and had ducks on it, so everyone thought it was a joke. And then he refined it and refined it and refined it, and eventually got an engineering firm to make up a prototype. It looked like something from a bloody science fiction movie. It looked absolutely fantastic. And all of a sudden, people were interested. But it was just as efficient as the one, and worked just only a little bit better than the one he had, but the ducks all over it. So people have very small minds. They can't see beyond a prototype. Fascinating. Now, developed initially to pump water from mines, the technology was adapted across so many industries and applications that it sparked the Industrial Revolution. Now, according to those working on the development of fusion energy plants, we're on the cusp of a similar transformation. I see this whole endeavour as having the characteristics of a general-purpose technology in the same spirit as Watt, says Lu Fong Chua, Chief Strategy Officer of TAE Power Solutions in Birmingham. Yes. Alan Turing and his Turing machine, the computer god, when he was like 24 or something in university, literally came up with the concept of computer science as a science, and thought of the Turing machine was a machine that did more than just numbers. He saw a universal machine, because people have carried that work on. So now we sit down, they all thought he was mad. Now we sit down with a computer that's not only does numbers on your spreadsheets, it's a typewriter for your word processing. It's an entertainment machine. It's a jukebox. It has music on it. It has video on it. Everyone goes, yes, so what? I do that every day. The first time it was a concept that computers could be multi-purpose and cover and change industries, literally, and create new industries. I'm sorry, you're crazy. This is what's happening here with fusion. Absolutely incredible. Fusion is the energy-generating mechanism that makes the stars shine. The cliche is that human-engineered fusion on Earth is always 30 years away. But if we can make it work, it promises such quantities of clean energy that we will finally be able to leave fossil fuels behind. Yeah. At the moment, keep the fossil fuels in until we perfect fusion. Forget your bloody wind energy and all that sort of stuff. The turbines freeze. They break. They burst into flames. And they're too high up for the bloody firemen to go and get them. And what happens if you get a little bit of snow or a bloody cloudy day? All of a sudden, you've got no solar. Don't get me started. Large state-sponsored efforts and increasingly private startups are reporting breakthroughs that many in the industry will now lead to, will lead to viable fusion energy. I've done a number of videos on that, where breaking through in areas, certain aspects of fusion. And when we put all those pieces of that puzzle together, we will have fusion. But what's happening is now we're getting all those pieces together. We just don't know how they're going to come together yet, but we're actually doing individual experiments, and those experiments are working. That's one component of fusion. That's another component. Check the videos out on the channel. It's very interesting. Yes, and now underlying their optimism, in 2022, the UK government announced the site for the spherical tokamak for energy production, or STEP, project at West Burton in Nottinghamshire. The demonstration plant aims to supply electricity, as Catweasel would say, for those of you old enough to remember. Oh dear. Electricity to the national grid by the 2040s. And in developing such fusion power plants, we are creating new technologies and solutions that can reach far beyond the task of energy generation. Yes, so it's not just for keeping the lights on. We're going to be doing a hell of a lot more with it. So you'll be able to do things like you can get a nuclear fusion plant, drop it down in size, right, and stick it in a car, or stick it in a plane, or stick it in a spaceship, in a boat, in a big ship. Fascinating. For example, TAE Power Solutions is a spin-out from America's TAE Technologies, which was founded in 1998 to develop commercial fusion power. Obliged to invent a way to collect and store 750 megawatts, the power needed to spark their experimental reactor to life, from a commercial electricity grid only capable of delivering 2 megawatts, the firm is now adapting its breakthroughs to provide more efficient batteries for the next generation of electric vehicles. And eventually, you'll be able to replace the engines. You probably won't even need the bloody electric batteries either. Fascinating. And as I say, I'll leave the link to the main article below the video, so you can pop in, check out the embedded links, go for a bit of a deeper dive if you want. Makes for an interesting read, believe me. It's interesting. All right, so we don't see these as side projects. We see these as happy byproducts that have a very intrinsic value on their own for problems and challenges beyond energy generation, says Chua. Now, in the UK, the Atomic Energy Authority, or the UK AEA, has established the fusion cluster at Culham in Oxfordshire to stimulate the growth of a fusion industry. Now, since its establishment in 2021, the cluster has grown from a handful of companies to more than 200, while the key goal remains the development of the skills and technology necessarily to build a UK commercial fusion power plant by the 2040s. Commercialising the spin-off is also a high priority. Look at this. Mitsubishi built a prototype MHD ship, the Yamato 1, in the 1990s, but the vessel's top speed was only 15 k's. Got to start somewhere. The prototype MHD vessel, that's interesting. Hopefully we'll find out a bit more about it. That's interesting. It's interesting indeed. Yes, one of the roles of the fusion cluster plays is telling people that not only is fusion coming, but there is value from it even years before we've got the first fusion power plants, because we've got these enabling technologies emerging, says Valerie Jamison, the Centre's Development Manager. It's a message that stimulates investment, as Greg Pfeiffer, founder and CEO of Shine Technologies, realized in the early 2000s. When he saw that developing commercial fusion power was going to be a long and costly path, it led him to think about how the technologies being developed could be deployed for profit along the way, so that investors could see a more immediate return on their money. It's hardcore essential to the mission of commercializing fusion. So yeah, interesting. So make a bit of money on the way, give a bit of confidence to investors, and then you've also got some money to invest back into your projects. Makes sense. Now, there are currently 4 key areas in which fusion spin-off technology is playing a role. Excuse me, I've yet to caffeinate. Oh, man. Gotta love a little bit of caffeination. Excellent. All right, so let's look at propulsion. One of the seemingly impossible things that a fusion reactor must do is confine a gas at around 100 M Celsius, not hot enough to melt any material. Fortunately, at the temperature, gas becomes electrically charged and so can be controlled by magnetic fields. Now, the strength of the field determines the size of the reactor and therefore how cost effective it is to build. Now, creating highly efficient magnets has been a core goal of Tokamak Energy, part of the fusion cluster and headquartered at Milton Park, Oxfordshire. In 2023, they announced the creation of a new generation of high-temperature semiconducting magnets that deliver stable magnetic fields 10 or even 20 times stronger than existing technologies. Not only do such magnets open a path to a viable fusion machine, but they can transform existing markets and create new markets, says Warwick Matthews, CEO at Tokamak. Yes, interesting. Interesting. One such idea is the creation of a magneto-hydrodynamic MHD drives, known to theoreticians since the 1950s. MHD drives use magnetic fields to create jets of electrically charged fluid that propel a vehicle. The beauty is that they have no moving parts, so suffer no wear and tear. Marine applications are particularly attractive because seawater conducts electricity far better than fresh water. I'm assuming that's because of the salt. Then again, I'm not a scientist. Let me know how that works down in the comments, please. Since the engines are silent, they promise a big cut in the damaging noise pollution affecting marine environments and, of course, diesel pollution and everything else. Since the 1990s, Mitsubishi built the world's first prototype MHD ship, the Yamato 1, but the program was abandoned when its top speed proved just to be over 15 kilometres or just over 8 knots. By providing much higher magnetic fields and therefore more thrust, Tokamak Energy's magnets could be game-changing. The company is currently collaborating with the US Defense Advanced Research Projects Agency, or DARPA, to prove the concept with a demonstrative device. And there's the reference to that little boat. Very, very interesting indeed. Wonder if they can work on that now and improve on it. Speaking of DARPA, you're watching this on the Interzones? Yep, DARPA helped start the internet back in the late 1960s, believe it or not. It's been around that long. The original concept was, so you don't have all your eggs in one basket. So the idea is if there was the middle of the Cold War, remember, where the Soviet Union, Russia, had all these missiles, right? Nuclear missiles. They still do. So the Americans. So the idea is if the Russians sent over a missile and took out Los Angeles, hopefully not, never want that to happen, but if they did, you'd still have command and control somewhere else, in another city in America. Nothing was centralized, you know what I mean? So I'm sure it's like if anything happened to Washington, D.C., obviously America would be able to move the capital to somewhere else, move it to New York or something, or whatever, you know what I'm trying to say. Principles similar with this. Same with the Interzones. The idea is that you upload a YouTube video, for argument's sake. It's not just stored in one place on YouTube. All right? It gets copied to multiple servers all over the planet because it's faster for local use. So if I upload a video like I have here from Australia, this video, it gets copied to servers all over the planet. So when you run this video in Canada, it's running off a local server in Canada. It's been copied up there. So if the Australian server goes down for YouTube or wherever, you can still watch it. It's quite interesting, isn't it? Yeah. Just takes a lot of strain off the systems. That's a similar principle to what DARPA was based on. Sorry, not DARPA. The original internet was based on with DARPA. The idea is you can have all this information stored everywhere, and interesting indeed. Yep. All right, David, get on with it. You've digressed once again. Dear oh dear. Medical applications. There are several possible reactions that a fusion machine can use to generate energy. In 1998, TAE chose to pursue the fusion of boron atoms with protons, which opened their eyes to an old research program into curing cancer. Atomic pioneers in the 30s showed that boron possessed a strong affinity for reacting with neutron particles to split lithium and helium. In 1936, Gordon Loker of the Franklin Institute in Pennsylvania pointed out the reaction's potential for destroying cancerous cells. As a lithium and helium recoil, they deposit their energy over a range of about 5 to 9 micrometers, the size of a typical cancer cell. This sudden release of energy destroys the cell. Now, while the boron could be introduced into the patient with drugs, finding a suitable source of neutrons in the mid-20th century was a big problem. Historically, the patient had to be taken to a nuclear reactor and exposed to the neutrons from its core. Hardly ideal. Yeah. You get a massive dose of radiation and you'd be dead. And that'd certainly solve all your problems with cancer, though, I can guarantee it. Fascinating. Now, the problem is all but solved. A key innovation from TAE's fusion program has been the creation of compact particle accelerators that can be used to generate tightly focused neutron beams. In fusion, they are used to fuel the reactors. We're able to take those beams and reconfigure them for medical purposes, says Rob Hills, CEO of TAE Life Sciences. Look at that. Tokamaks high energy temperature superconducting magnets. Absolutely fascinating. Absolutely fascinating. Yeah, now the company is currently in discussions with university hospitals, Birmingham and University College Hospital London, to install experimental apparatus. Meanwhile, Shine Technologies is producing lutetium-177, a medically useful isotope, in its facilities in Janesville, Wisconsin, and Veendam in the Netherlands. The lutetium is also used to target cancer, similarly delivered on a drug that binds to cancer cells. Unlike boron, it does not need neutrons to activate it. Instead, it is radioactive and decays with a half-life of around 6.5 days, emitting a high-energy electron that rips the cancer cell apart. It also emits a gamma ray, opening the possibility of a medical imaging device that can track the progress of cancer and the effectiveness of the treatment. Having such a short half-life, however, means the isotope does not exist in nature and so must be created using fusion technology. Nuclear fusion, by the time it gets here, we've reaped a lot of benefits beforehand, and that's why we can make money from that. So therefore, the money we get from that, we can invest back into nuclear fusion. Absolutely amazing. As I say, I'll leave the link to the main article below the video so you can pop in and you can check it out at your leisure. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News Update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video. I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
5, 4, 3,